So let's solve LeetCode 242 valid anagram. So given two strings s and t, we want to return true if t is an anagram of s and false otherwise. What does an anagram mean? If we hover over this, LeetCode says that an anagram is a word or a phrase formed by rearranging the letters of a different word or phrase using all the original letters exactly once. I don't know what that means. Let's just take a look at an example. So the input S is equal to ANAGRAM. T is equal to NAGARAM. And then the output is true. Why is that? Again, we'll just look at the definition of anagram now. A word or a phrase formed by rearranging the letters of a different word or phrase. So anagram is basically a rearrangement of all of the characters present in this string and vice versa. So essentially what we are seeing is that if we have anagram like this and we have NAGARAM like this, then they are anagrams. Why is that? That's because an A is present over here and A is present over here. N is present over here, N is present over here. A is present over here, it's present over here. G is here, G is here. R is here, R is here. A is here, A is here, and M is present here. So what we have discovered is that if we just find out the counts of each of these characters that are present in both of the strings and compare if their counts are equal, we can get to know if these are anagrams or not. So all we need to do is check that, hey, A is present 2 times in the S string. So all of this is for S string. Let me just format it really nicely. So for S string, we are checking that A is present 2 times, then N, or actually A is present 3 times because it's here, here, and here. Then N is present once, G is present once, R is present once, and M is present once. Then we'll do the same thing for T. So here we'll check that, hey, N is present once, then A is present 3 as well, G is present once, R is present once, and M is present once. Now, if you know about the basic data structures that are present in Python, you already know what this is. We have established a mapping here, and a mapping can be created using a dictionary in Python. So that's what we're going to do. We're going to create a mapping of these two strings that are present, finding out each of the characters, and then we'll just equate them. Python handles all the equals thing, so it will automatically check that A is present 3 times here. Is A key present and its value is 3 or not? So Python will do all of those equal operations for us. So that's very easy, but I have a few things in mind. First thing is that, are we guaranteed to have all of them lowercase, or can they be uppercase? And do I have to maintain that case sensitivity? Because here's the thing. If I have to maintain case sensitivity, that means I can simply compare this A3 to this A3. But if I don't have to maintain case sensitivity, then that means I can convert this small a to big A. And let's say this was a capital A, I could convert this, well, to capital A. So, I mean, we have to keep that in mind. Should it be case sensitive or case insensitive? And that's what we have to figure out. And the next thing is a very good observation. The observation is that if it's an anagram, the number of letters is going to be the same, right? If the number of letters is going to be same in S and T both, only then they are going to be anagrams. So first we can just have a check that, hey, if the length of S is equal to the length of T, then we can continue forward. And if it's not equal, then we'll just return false. So let's go step by step. The first step is, well, are we going to have lowercase letters, or are we going to have uppercase, and do we have to do something about case sensitivity? And the answer is written here. S and T consist of lowercase English letters. So yeah, good. Let's go ahead and implement the second one, which is if it's an anagram, the number of letters should be the same because we are essentially rearranging the letters. The count of all of the letters is same. That means, well, the length of the string should also be the same. And that's why what we're going to do is if length of string is not equal to the length of t, in that case, I'll quickly return false, that I don't want to execute further. This is not going to be an anagram. The lengths should match. And once we have validated that the lengths are matching, we can just use one for loop to iterate through both of these strings now. Because earlier what we would have to do is go over each character in this S, go over each character in this T, create a dictionary for each one of them. So the time complexity would become O of n plus m, where n is the length of this string and m is the length of this string. But now since we know that both of these are going to be equal lengths, in that case, we can just have one for loop, which is O of n, and n is the length of the string s or the length of t because both of them are going to be equal. So let's go over this. We have for I in range length of s, and the reason I've done for I in range and not done for string in s, for example, is because I want to get the index, because in one for loop I'll be creating the dictionaries for s and t. Also, let's go ahead and initialize the variables to create the dictionary. So we have tdict and sdict. After that, I can just say that, hey, sdict at s at I is going to be sdict dot get s at I comma 0 plus 1. What have I done here? So I'm going over all of the characters in the string, and then what I'm saying is that in this S dictionary we have A, right? So I'll create a mapping. So the mapping is going to be that, hey, if we have anagram, I'm creating a dictionary here where A is going to be string at 0. So that's what I've done here. S at I, because in the first iteration I is going to be 0. So S at 0, which will give me A. At that position at A, we want sdict.get S at I. So I want to get the already existing value in the dictionary that's present for A. And if it's not present, I'll initialize it to 0 and add 1 to it. So A will be 1 in our case. The same goes for n. In the second iteration, n will be 1. But then I encounter A again. And if I encounter A again, what am I doing? I'm doing sdict.get s at I. So I get A from this dictionary. So I get 1 as the value. And then I add 1 to it. So now this becomes 2. And then I go over G, which is 1, R is 1, then A, again, this will become 3, and then M is going to be 1. So that will be the S dictionary. Now the same thing will be carried out for T dictionary. So we have T dictionary where at T at I, T dictionary, T at I plus 1, and that's pretty much it. We have created 2 dictionaries. Now we can just say return tdict is equal to sdict. At this point, we can't return true. Remember that. We have to return this equal to value because it can be the case that 2 strings have the same number of letters, but they're not anagrams essentially. For example, you might know that rat and car are not anagrams because C is present here, C is not present here, T is present here, T is not present here. That's why we can't just put in true here. We have to compare both of the dictionaries because for rat, the dictionary would be R is 1, A is 1, T is 1. And for car, it would be C is 1, A is 1, and R is 1. These 2 dictionaries are not equal. So it will return false. So that is our entire solution. Let's run it and see if it works out. Accepted. Let's submit it. And yeah, that's pretty straightforward.